some other leading question.
Sure. Okay, so I don't know that much about machine learning, and one area that I know nothing about is so I understand, feeding data to a database, but can you describe like the process computationally for the recall to happen? Like, how does the machine actually learn and then adjust its new theory about what's going on for the question?
That's kind of an open-ended question. I mean, typically what you're looking at, you have like the most common form of machine learning is supervised, right? I mean, we can talk about time series, but the thing most people think about, like, is this spam or not? The classic one is like, is this spam email or not spam email, right?
Yeah.
So typically for machine learning, it's not a magic process, right? Someone sits down and thinks about the problem, right? Because you're a human and you're thinking about a real world problem, and you think about all the different features that could go into it. All right, so like, the words, obviously a bag of words from the email, like the existence of a URL, because like if you just parse the email just by breaking it on delimiters, the URL will get broken up. So you end up like trying to figure out a bunch of features that you can possibly extract, or maybe try to augment it. It's like, what if we collected like the SMTP records or whatever instead of just the delivery stuff, and then you store those. Right, you have to store those records somewhere. Now, the machine learning part is basically is you've got some label on it, right? Someone's like spam or not spam, spam not spam, and what you're trying to all machine learning is it's trying to find a function that takes those input features and tries to say, is it spam or is it not spam? So, like for example, like I'll give you an example that's not spam exactly, but it was something we did at Yahoo / it was an Overture thing, but then we did actually implement it at Yahoo. Was this like commercial intent filter? So it's very similar to spam, except it's taking the queries that come from the user and trying to predict, are they really interested in like buying things, or are they trying to do academic research, right? Or they're sort of interest-based research. And so we actually just did with bag of words. It was really easy, just bag of words on the results set that came back, right? So you look at the search results that come back, and you say, you just literally break them up into words and tokens, and you run machine learning. I mean, I can't remember what I used at the time. You can use it. Like, there's a lot of like, is it SVMs, or is it like, decision trees, or is it decision forests or whatever? But they're all doing the same thing, right? They're taking there's a big high dimensional space, and they're trying to draw lines through it, basically. Regression. Right? They're doing regression, but they're like in these binary, it's logistical regression.
Okay.
They're all basically doing the same thing, right? So, and a very simple thing with bag of words is you're simply like, you can imagine just counting like, well, if I see the word and there are like, 50,000 out of 100,000 documents have and in it, and 50,000 out of 100 documents have it in when it's not commercial, it's not much of a signal, right? And literally all you're doing is, like, for something like naive Bayes, there's very little computation to be done. For something like SVM, like a Gaussian kernel SVM, there's a lot of computation to be done. But they're all still, basically all they're trying to do is find a set of parameters to the inputs, saying, is this important or not to the output?
Yeah. Okay.
Where's it going? So you'll never guess, I bet you can't guess which common word would predict whether or not something was a research versus a commercial query.
Out of all the words.
Sale.
Buy.
Meeting. Sale. Shoes.
Attachment.
Form of a question.
Unsubscribe.
So it was there were two standout ones, which was all, ALL,
Really?
and your.
Wow.
Oh.
And y'all, Y apostrophe?
Y-O-U-R.
Your.
Oh, your.
So the two reasons we could get from it, I mean, because this is the other thing, is like, remember, we started off with a real world problem, which we were trying to figure out, and we sort of like did some feature extraction, but in this case we didn't go too far. But the interesting bit is when you go back and you look at the model that's produced and you think, why is the model saying that? And in this case it was all rights reserved, which was highly significant. Like, a commercial document almost always has like all rights reserved. And the reason why your was the top one is because it was always the pitch. It's like your needs, your input, right? So it was like,
That's
I mean, they probably accounted for like 50% of the ability to separate into the two classes. So it's kind of neat. But does that help your understanding of what supervised?
It does,
that's
absolutely.
That's supervised machine learning.
Yeah.
Which is where you have like two classes, or you can have like multiple classes. But the simpler one, you have binary classes.
Mm-hmm.
Then you have like regression, which is like trying to predict some like price line or what's there's a continuous thing. Then there's like time analysis, like time series analysis, which I suspect Uber does lots of. And then there's like the separate, but all of these are supervised, right? You have like a target. You have like a target that you can identify, and you're trying to predict what the next, and give another example what the target will be. The other, like a known target. The alternative is like clustering, right? Where you don't actually, you just got like a big mess of data, and someone says like, find some patterns in there. And trust me, you can find a lot of patterns in there, right? It's basically you need to take the power set of all the objects you've got, and that's how many different patterns you've got, and they're all equally legitimate. That's the part of the problem with the clustering.
So you have to decide as an analyst what patterns you're actually
exactly. You're
regarding
effectively like
relevant.
saying like, why am I looking at this data in the first place? And it ends up being ends up being more of a form of like a feature reduction. So you're trying to reduce the total space down to something more reasonable.
Okay. Wow.
I have to say, if you haven't watched Andrew Ng's machine learning video from Coursera, everyone should.
Oh.
It's really accessible. Like, I've taken like about 5 or 6 different like machine learning classes in my life, like semester-long ones, and that was by far and away the sort of most unified and clear. Like it's like this grand unified theory of machine learning, which is done really well. I have to say, I was because he starts off talking about regression, and I'm not a regression person. I'm from, like if you meet people who are from AI, they're all about decision trees and stuff like that. But like if you meet statisticians, they're all about regression. But he starts off from the regression point of view. But he makes such a clear transition from regression to sort of binary classification. Looks at how that relates to decision trees and like turns it into SVMs. It's just really really neat.
Yeah, I did it, and I'm